Hello, ladies and gentlemen. Today I wanted to talk about class composition in C++ with templates. You can do a lot of things with templates in C++, especially templated functions and templated classes such as vector or the standard filtering functions like sort or remove if. Those are all templated. But today I wanted to build, or at least get in the mindset of building an API or a library that builds itself at compile time. So I know things like Vector are doing this already and doing this very good and using their highly optimized allocators, but I wanted to have a, let's say, simpler approach. Simple but not necessarily easy. So first we should talk about what using the using the word type in C++ is maybe a bit wrong in this context, but I just wanted to talk about types and what you can do with them. So the little table you see in the background is what I think is an accurate representation of what we can do at the moment with modern C++. So we will be evaluating what you can do with the, let's say, types of things we can use in C++ and evaluate their behavior at runtime and compile time. So we could we start with a value. So a value could everything from be a constant char pointer, basically an inline string, or something like a number, like a 5. And this is at runtime, it is fixed. You can't change this value except if you modify your binary, but that's not part of the standard, so we will forget it. The runtime type is also fixed. In this case, it's an integer. For, I think, the default initialization type for a 5 would be integer. If we would write, let's say, 5.0f, I think it would be something like a float. So everything for this type is fixed. So the runtime value is fixed, the runtime type is fixed because integer or float or something, and at compile time you can't do something with it. You can use it in a const expr context. If you make the variable that contains the value const expr, you can maybe use this, but the value itself will not change. So it's runtime and compile time fixed. So if we take a variable and take a simple variable that's not const expr, and not const in this case, so it has a runtime value that is variable because that's why it's called a variable. So if you have an integer, you could put a 5, a 10, or a 2,200,000,000. I know a 32-bit integer has its limits, but 2 billion should be okay. The runtime type is fixed. It's always fixed, and we are excluding here types like variant or other libraries that or unions that are basically a type of type but can contain other types. So we are omitting that for the moment. At compile time, this cell here should be fixed, but as I said, we could use it in a const expr fashion, and then we could do some computation at compile time. Also, the compile time type is fixed. I don't know any I would have said I don't know any way to modify the type at compile time, but if that variable is declared auto in C++ and other languages like C# have var, that value could change at compile time, but that's a type, that's a thing for itself. It's type deduction, but at the end of compile time the type would be fixed nonetheless. So let's come to templates. Templates is in a way the next step. So we have values, we have variables. Basically values are everything fixed. A variable is a fixed type but a variable value, and a template is a variable type and a variable value. The only thing that's fixed and that's just a C++ thing, that its runtime type is fixed. I think a template type in Java is also variable, because the whole function that is built at runtime. So if you build the function at runtime, or the class at runtime, then also your template runtime type could be variable. But we are speaking about C++, and in C++ the runtime type is fixed. That contradicts itself a little bit with a variable compile time type, but a template is basically nothing more than a way to say, if you use this class or function with another type, then the function or class will be built for this type, but it will be built at compile time for the runtime. So it's fixed at runtime, but with one class definition, one templated class definition, we can create multiple runtime definitions. So we are building something like a tree. I think that's it for the moment. I'm trying to think of things that we could do in the future, maybe that we would put in this line. Because value, everything fixed, variable fixed, variable value fixed type, template, variable type. But what would be the next step? I think that's another dimension, or maybe another abstraction. But in my mind is limited to just so much as I can think. And for the moment, enough of this philosophy. Let's take to the code. So my CPP web toolkit is was added a web application. That's basically just a web server, but here I am using the same thing I will show you on Godbolt. So if you've never been to godbolt.org, it's a real-time C++ compiler, and it can compile other things too, like Go, Pascal, and Swift, and so on. But we are just interested in C++ at the moment, so ignore the assembly that's generated on the right for the moment, and I'll walk you through the small, let's say, framework I wrote here on the left. I think to make it more readable for you, I should increase the font size, and at this point you should be able to read it without a problem. And what I did is I wanted to create a web server class. So this basic web server should define its behavior depending on the types the user wants the web server to use. So while programming my own web server, I came to the problem that a user could want multiple types of sessions. So if you write a really simple program that has maybe 1 to 5 or 6 users, then it's probably okay to store your session in the RAM, and you don't need anything complicated like authentication or all this stuff. So what you would want to do is just make your sessions some kind of int string key value store, like an unordered map. You could use as a session ID, you could use an integer, and as session object private data or something, and you don't have any special requirements for speed or something. You could use a standard string as session object and put just a key value stuff or a JSON object or whatever you want into this string. So that's a simple way. But if you're writing a framework and you're in the mindset of writing a framework, you want your user to be able to make simple things and also complicated things. But I myself was too lazy to write the complicated stuff, because you could store your sessions on disk. You could just write a text file that you either completely read into memory and then use that, or every request the file is read again because your web server isn't used very frequently, so it's used like every 5 minutes once or something. So to save your computation time and RAM, you just read in the text file, read your sessions and compare the sessions, and then throw away the text file or modify it and write it back. But you could also want something more complicated, like storing your sessions in a database, or a complicated RAM store with an unordered map as an index for your session keys and session objects, and so on. So what I needed to do was to make the user able to define types that my web server should use. So in this example, I will only use session IDs and session objects to, well, prove my point. But in a real application, this session store or session provider would be a whole class that I just take, and that just implements some stuff I need, and I would just use that stuff, like methods that return or validate a session request. So what I wanted to do was use everything that my web server, every type that my web server uses, I wanted to put inside class templates. So I would just have a really, really long list of template class, blah, 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 blah. And I also would have needed to validate them. So for every class template I would create, I would need to check with an able if t, if somebody doesn't know it, with this little template magic here. You can check at compile time if something implements a class or has a method, or is a pointer, or is a reference, or whatever. And this is already long enough, but I don't want to make my web server definition in the code look like a total monstrosity. So you have your web server and then 5-6 template classes, and if you name your classes properly, they have sometimes long or longer names, and that would just be ugly code. So I think I thought to myself, in the early days we had ini files, or now we have XML or JSON files where we put our configs. Couldn't we just do that for types? Because I just want to put my types in a config or config file and then say to the web server, use it. In this case, it's not like a big web server like Apache or Tomcat or something that take a text file with some stuff in it and do it at runtime, but we want to define compile time behavior, because compile time is where the speed is. So, well, and templates are the way of making things speed up, except the compile time itself. But what I thought I could just use a config class. So I would create a config class, and then you could inherit from that config class and implement your own stuff. But if I would have used classic polymorphism, then I would, every time I request something from a type you give to me, I mean you the user give to me, the library writer, I would have to pay the performance fee of the virtual table lookup. And again, this is C++ because and we want something, we want our stuff quickly. So I thought, how can I store a type? Because if we want to store a value or multiple values, we have variables. But if I want to store a type, I would use something like decal type, or in this case, using. With this I modified my code. With this using here, I basically created a type variable. It's a variable, but it contains a type, and this type is variable at compile time. It's a type, basically. And to have default behavior, I already assigned it a type. In this case, it's my session base, because that type storage is called session. And I made my own session base with a session ID and session object, as I mentioned before. This is just a simple example. Session ID will just be an integer, and in this thing, in this string, I would just throw in some JSON or something. And yeah, that's basically it. So I would have, if I just would have used the config base as a web server config, I would have got a default behavior. And the user could have just used the web server basically without any template arguments. So he just, and that's something I wanted to make sure for everybody, he just needs to use the type. He and if he's a beginner and he doesn't know how to use templates or stuff, he would have just needed to write web server ws semicolon, and then he could use it. He could call start, he could call register page or something, or whatever the web server will do. and he would have been just fine for the first part. So, but these, yeah, you saw these are called _base. So these are base classes. So we are using polymorphism, but not virtual tables, because virtual tables are only built if you put the keyword virtual in stuff here. But we can't, at least at my knowledge, we can't have using virtual. So I can force the user of the class session base to at least implement session ID, our type storage. And so we are using classic polymorphism and using overshadowing. Overshadowing in this case is a little bit tricky, because in my web server, I know what name I'm using, but if the, let's say, inheritor of my session base uses session ID with a lowercase d, and I changed something here and we don't get a compile time error, so we don't get a compile time check for this. I don't have a solution for that yet, but we're using overshadowing. So overshadowing would work like this. We have, ignore that session object, that's just a simple object I created out of my mind. And here you see the overshadowing, because it publicly extends VWS session base, and well, again, that's our session base, and we are just overshadowing the type storages, or the types that were defined in our session base. So we created us a simple session, and we made a simple config from WS config base, and in this case we are also overshadowing our session with our newly created simple session. And well, yeah, that's our config base here. And then we are creating for easier use a new type. Is it a new type? No, it's not a new type. We rename it into simple web server. So the user can just write web server in this code, simple web server, whatever, and it should work just fine. And what we did here, we gave our web server our simple config. Our simple config, if we go into here our enabled if t checks if our config that was given to us here, that's the simple config we defined down here, is base, if this config is base of WS config base. We did that because if we remove this, we will get a compiler error that basically says you can't instantiate because what I wanted to check was wrong. So this checks for implementing the config base, and as you just saw, if we remove from our simple config the config base, then it throws an error. Sadly, it just throws that error at compile time, but compile time is better than runtime. And if an IDE like Visual Studio is able to do it, maybe. I had some problem with templates and Visual Studio lately. And the same is done with session base, because session base implements at least session ID and session object, and we need to check this as well. But what we can do is we can write type name config session. So this writing it this way exposes the type we assigned to the session type storage, to this one here. And we are checking it if it inherits from session base with this is base off, and the value just gives us a Boolean value that is checked. And again, if that's false, then we get a compile time error. And then just to use it, I create an unordered map with our session ID as key and a session object as value, and called it sessions, but this is just to test it. And if we are looking at the assembly code, it's a lot and it looks awful. At least in my eyes. I'm not used to read assembly, but I can say that this is a lot for basically saying we have a web server that has just one variable, and that one variable is an unordered map. But I know an unordered map is no simple type like integer or something. It's complex, and because it's so complex, it's also fast. What we can do is we can also check at compile time with static assert if our given session ID here is the same as an int, and in this case it throws an error. Let's look at the error. The error says what I wrote in here. Error for session ID type, and that's what I wrote here. So that's just a check to see if our session ID is really transferred through the config into our class implementation. So our session ID was a float down here for our simple session because we used our simple session in our simple config. If I change this to float, then it compiles just fine. So this would be about the end of this video. I hope I could inspire you to use it yourself if you're a library writer, or if you come from another language, maybe motivate your your language creator to implement something as well if it's not already implemented. I mean, Java and C# do this at runtime, I think. C++ doesn't have, at least yet, something like this for runtime. It has runtime type information, but that's another story for itself, and it has its costs in performance. But this is totally done at compile time, so at runtime it costs us absolutely nothing. Ha! Absolutely nothing. Say it again. So I want to thank you for watching if you made it until this part of the video, because if you are new to template programming, this was maybe a bit much to take in, but if you have questions, you're welcome to put them in the comments below. And until next time, have a good day, have a good week, and bye.